ortho. Let's do red and green. I like red and green, Christmas colors. So let's say we have a BR here. This one you used or whatever. And then let's say that we have a BR here. And then let's say that we have a bromine here. I'm using bromine because like that way it's the same for all of them. But you could pretty much put anything here. This is related to like your ortho, meta, para stuff. So if this is right next to something, this is ortho. If there is a carbon between, but it's only one carbon between, this is a meta.
Wait, do we have to know this?
Yes.
Yeah. If there is two carbons in between, 1, 2, 1, 2, this is a para. And really, we only really use this for cyclohexanes, so like with benzenes. Because really, the original terminology for para was the idea that these two sets are parallel to one another. Yeah, so it doesn't really matter. The idea is that whenever he put those on the thing and people were like, well, why is this 2 bromide and, you know, like whatever the other ones were, because he used different things for every single one. So that's why I'm trying to use the same thing for all of them, with the idea that all of these are toluene, right? Because this main thing is a toluene. And so the idea is, can you identify what the main structure is? And then your idea behind it is it's 1, 2, or 1, 2, 3, because you're using the main structure as your number 1.
Okay.
The idea is that when, as a chemist, when we label this, we don't actually ever call it 2-bromotoluene. Like we don't really ever call it 2-bromotoluene. Don't do that. You say it is ortho bromotoluene. And that ortho
This was in our lecture?
No, he's explaining it, but he's
I'm
just
explaining it. I mean, we did talk about this. What are y'all talking about?
because he was the face he made to me.
I don't remember. I was like, I didn't catch this at all in lecture if this was talked
like
about.
right after you talked about like naphthalene and like
okay.
or did you talk about naphthalene before or after that?
Those are the benzenes.
But it was like whenever you're talking about all the benzene and stuff, like
Okay.
and he brought up like toluene and phenol and all the other ones like aniline and cumene and all that.
Okay.
So the idea is this is an ortho position. This one is the meta position, so you'd say it would be meta bromotoluene. I'm just putting the dash in there because I don't have enough room to write the whole thing down. And then this would be para, so then this would be para bromotoluene. In terms of if he gives you something like this on the test, you just have to
it would
know.
be more of like a naming question.
This would be more of just a straight up naming question. Like he shouldn't have this as a substituent group on something else, because that's just, he could, but I think that's getting too into the weeds.
Ortho next to each other. Meta. And I can see, could you mention like the actual like numbering? So it'd be like the 1 and 3 where they connect.
Yeah. So like the idea is this is 1, 3, and this is 1, 4, or whatever. But in reality, you're just going to call it para, meta, and ortho.
Ortho if there's no carbons between it. Meta if there's 1. Para if there's 2.
Yeah. And then if he gives you something where there is, for this, where there's another group on here and it's like an OH group, you have to know the order of increasing priority. So like if this isn't here, and this is still a meta group, and this is an OH instead. In terms of that list that he gave us, he gave it to us in increasing order of priority. To where toluene is the lowest priority, and aniline is the highest priority. And on his little list, they gave us some things to memorize.
Mm-hmm.
So the idea is that phenol is farther on the right of that list compared to toluene. So this is no longer a hydroxytoluene. This is now a methylphenol. So that is the thing that I think people are going to get thrown off on, is he's going to give them something like this, where they're going to be like, I don't understand what this is, because they'll see this, and they'll be like, which one is it, toluene or phenol? And the idea is that phenol has a higher priority in terms of naming compared to toluene.
That was in the lecture too?
Yes.
Yes.
Okay.
So the idea is where's that slide? With this slide here. So toluene, cumene, styrene, phenol, anisole, and aniline.
Which module is that one? The first
Module
one?
7, like towards the end, like last third somewhere. I don't have a slide number.
So
for
that's
you.
the order of priority right there.
That's the order of priority right there. So toluene's the lowest, then cumene, then styrene, then phenol, then anisole, then aniline, in terms of priority level for those 6. Whether or not he's going to make that part of the test, I don't know.
Mhm.
But it is something where he, like, given the examples that he gave for the ortho meta para, like, that very much could be part of the test, or whatever. Because, like, if you look, like, he gave the 2-bromo-toluene. I'm trying to show this to the camera too. And then he gave the 3-methyl-styrene. Well, if you don't see that styrene part there, it looks like a toluene, right?
Mhm.
Sorry, my computer's touchscreen, so I'm trying not to set it off. So the idea is that styrene, which is the third one, has higher priority than the toluene. So then the toluene becomes a methyl group, and the styrene is our main group. And then same thing for the phenol, has a higher priority than styrene. Anisole has a higher priority than phenol. And aniline has a higher priority than anisole. And in terms of remembering these, just know toluene's a methyl group. Cumene, one of the people that I've talked to said it looks like someone spreading their legs. It was one of the girls that actually said that, so don't get
April said that.
Yeah.
Better than mine.
It was
April said that.
it was April that said that. And then
Shout out April.
the styrene, Danica said it looks kind of like a steering wheel with a shifter or whatever. So like like your old like shifter
They said
thing.
it's like a coconut.
So I kind of like that one. And then the phenol is just because it's the phenol is that alcohol group or whatever. And phene is another way of short forming benzene. And then anisole is the SOLE, so you know it's the OCH3 group. And then aniline is just that NH2 group in terms of like what's on the end of that benzene ring or whatever. But in terms of naming this as a substituent group inside of a bigger molecule, I'm not expecting him to do that, but I am expecting to maybe be 2 questions of this, and he's gonna say, what is the name of this compound? And I could see him putting, like hydroxytoluene, and people going, well, I see the toluene group and it's got an OH on it, so therefore it's that one. And then the other answer that's gonna be there is gonna be methylphenol, and that's gonna be the right answer. I could see that being a question that he would ask. Does that make sense?
Mhm.
You're like, no.
He's like, no.
He's like, no.
You just need to know what's their priority.
Yeah, so you just have to know which is priority. And like I said, from left to right on that little list there, that's your priority. And just think about it in terms of what do you have as functional groups there. You're going from something where it's just carbon to oxygens and nitrogens. And why the aniline has higher priority, I don't really know. Because I always thought that oxygen had higher priority than nitrogen because it's heavier. but I think it has more to do with the fact that your nitrogen group is going to be more of a dictator in terms of bonds and stuff. Like it's more likely to form bonds with something, whereas like oxygen really is very reactive. So like phenols, that oxygen is going to lose that hydrogen, or it's going to use that for some sort of hydrogen bond interaction or something like that. Whereas your nitrogen, like it's that NH2 is pretty stable, and if it does lose a hydrogen, it's going to do it in the process of making a carbon bond or something like that. Like it's not doing it just to be reactive. Like you have to have some sort of something happening to make that reactive or whatever. So, yeah. All right. Y'all think that's good for this video?
Mhm.